Sorry, we start out with parallel. Let's do them in the correct order. Parallel or competing reactions. So in this case, we have our methane that we want to use to create some formaldehyde, so react it with oxygen, and we'll get some water out as well. But in this reactor, we also have our classical combustion of methane. So we just have methane reacting with two oxygens, giving us CO2 and 2 water. We're told to assume 100 moles entering of an equimolar mixture, so 1-to-1 ratio of methane to oxygen. And someone has been kind enough to do some experiments that tells us 90% of the methane will be converted, and we expect a yield of formaldehyde of 0.855, so 85.5%. So we're gonna basically do what we've been doing all along. Let's just make sure I can see the assignment, and we have our Excel. I already copied in the information, so we have it here. For something like this, I still just have a feed stream and a product stream, and I just want to put in the percentages of everything that I have. So we have our methane, we have our oxygen, we have our product, which, let's put a percentage in front of that. We have our, now everything's going wrong. We have our product of, what was it, formaldehyde. We also have some water. Let's just use the chemical notation. Anything else? We need our CO2 as well. So those are the different species that we have. We know that we start out with 100 moles, and we know that it's an equimolar mixture. So 50% methane, 50% of oxygen, nothing of the rest. And then I can easily calculate how many moles I have of the different components. That's fine. So I just take the total amount multiplied by the percentage I have, and I can fill it right and down. Everything is now calculated there. I don't know how many moles are gonna be in my exiting stream, and all of the percentages here I also don't know. I'm gonna say, 1 minus the sum of all the others. There we go. So the percentage of methane is now not an unknown, but the rest of them are. So that's pretty much the information I'm being given straight off the bat. Let's take our components here, copy, paste them transposed. There we go, transpose. And then I have carbon, hydrogen, and oxygen that I want to keep track of. 140, 002, 1, 2, 1, and 0, 2, 1, and 1, 0, 2. There we go. So that's just the number of atoms that I have in my different components. And finally, I can take my streams, copy them down here, and I can say, okay, for instance, how much carbon do I have? How much hydrogen? How much oxygen do I have in my two streams? And in my feed stream, I'm gonna use the sum product that we used last time, take all of my components and transpose the other array down here and finish off the the parentheses, fill right and down. So these are the amounts of carbon, hydrogen, and oxygen entering. These are the ones exiting. And I can then do my balances, basically saying that minus that, fill it to the right. That gives me 3 equations, 1, 2, 3, 4, 5 unknowns. I need to come up with some more equations. So I'm gonna look at this description and say, well, for instance, I know I would like to convert 90% of my methane. Another way of looking at that is if I'm converting 90%, I'm not converting the final 10. So I can do a 90% conversion equation, And I'm basically gonna say 1 minus the 90%. That's how much that won't be converted. I have 50 moles entering. I know 10% won't react. That means I should be left with them in that one. That gives me one equation. The other equation I'll use is my 85.5% formaldehyde yield. Here we have to be a bit careful on how we are defining yields. So you have to remember from chemistry, the yield is the theoretical maximum. So I have to look here and say, okay, in theory, how much formaldehyde could I get created? And I can get, if everything was converted, I can get, what is that? 1-to-1, so I can get 50 moles of formaldehyde being generated. So I basically want to take 85.5% of those. I'm just going to use methane. Oh, I need an equal sign, multiply. So I'm going to use my methane and say optimally everything of this is converted, but only 85.5% gets turned into formaldehyde. So I'm going to take that, subtract the amount of formaldehyde I end up with. That's my other equation. At this point, that one can move away. I have 3, 4, 5 equations, 5 unknowns, and I just have to set one of them to be equal to 0 and then the rest. So I fire up Solver. My first equation, value of 0, those 4, value of 0, and the final equation, value of 0. The variables that I have, all of the yellow ones there. We'll see if Excel is with us. It sure is. Excel found a solution.